Okay, right. Now we're in question 10. And now in question 10, they say that an oil tank structure, as shown in the diagram below, consists of a cylindrical body of length h meters and two hemispherical ends of radius r and has a volume of 1000 meters cubed. And they say that determine the value of R such that the total surface area of the tank is a minimum, showing all working and justifications. Formulas: surface area of a sphere is 4 pi r squared, surface area of a cylinder is 2 pi r squared plus 2 pi r h. Then they say that the volume of a sphere is 4 over 3 pi r to the third. Volume of a cylinder is pi r squared times h. Now remember, they say that these are spherical, hemispherical. So if you were to combine those hemispherical, they will actually give you a sphere. All right, and then that's a cylinder there, right? So if we had to actually calculate the volume, let me say, use the volume of the shape of the oil tank of the oil tank, it will basically be just the volume of sphere plus the volume of cylinder. All right, because or what you could have done, you could have halved the or just to make it clear, or you could have just halved the volume of a sphere to have a volume of a hemispherical, but then you were gonna add the volume of this hemispherical and the volume of that hemispherical plus the volume of this cylinder. If you did that, it was gonna still give you the same thing, because basically if you plus the volume of the hemispherical ends, both of them, the two, they're gonna basically give you the volume of a sphere. So that's why we're gonna say the volume of a sphere plus the volume of a cylinder. And if you do that, let's just say V equals to 4 over 3 pi r to the third plus pi r squared times h. Now also remember, we are given that the volume is 1000 meters, so we can actually equate all of this. So we can say 1000 equals to 4 over 3 pi r third plus pi r squared times h. Now what we need to solve for is we're gonna solve for h. We're gonna actually make h the subject of the formula, because in this question they say it looks like we're gonna have to do, because this kind of a question that we call it an optimization question. Because remember, the keywords that you need to look out for here, they say that find the total surface area of the tank is a minimum. So basically we're gonna do the first derivative, and then we're gonna have to solve. So, and the way that they're speaking, they say determine the value of r. So basically we're gonna need to do the first derivative in terms of r. So the only way is for us to solve is to actually make h the subject of the formula in terms of r. Do you understand? And then in a way that you can do that, you can now have it this way. You can say pi r squared h equals to 1000 minus 4 over 3 pi r to the third, right? And then you can divide both sides by pi r squared. Pi r squared dividing both sides by pi r squared. If you do that, you're gonna have h equals to 1000 over pi 1000 over pi r squared minus 4 pi r third over 3 pi r squared and then we can simplify that and have it as 1000 over pi r squared minus, if you do that, those are gonna cancel out, they're gonna cancel out, then the 3 is gonna cancel out, then you're gonna just be left out with 1. So you should have an at the end as 4 over 3r. So that's the answer that you should have in terms of r, I mean to say. Okay, hopefully that's understandable. And then now another thing, they say that we need to determine the value of r such that the total surface area of the tank is a minimum. Now I want you to look at this. The total surface area of the tank, it will be the surface area of this hemispherical end and the surface area of that hemispherical end, and then we're gonna you do also the total surface area of this part of the cylinder. Now remember, the cylinder, we are given that the area of the surface area of a cylinder is 2 pi r squared plus 2 pi r h. Now what we're not gonna use in that formula is this part here, because basically those parts are covered by this hemispherical end, so we're not gonna need it. So the only part that we're gonna need is this part of the formula, which is 2 pi r squared, which is this part here. So I can actually put, let me use a purple color, so I can actually use this 2 pi r h, and then I'm gonna add it with the if you had to do half of the surface area, it will be 2, yes, it will be 2 pi r squared, and then that also will be 2 pi r squared. So if you do add them, so we're gonna say total surface area of tank, and then if you do it, you're gonna do the 2 pi r squared plus 2 pi r h, and then plus 2 pi r squared again, which is basically the same as doing the surface area of a sphere with only this part of the cylinder. So at the end we should have 4 pi r squared plus 2 pi r h. All right, and then what we can do now is we can substitute h, which we determined in our previous question. So let's name the total surface area as SA, total surface area. So let's just say SA, then we're gonna say equals to, so we're gonna say 4 pi r squared plus 2 pi r, then we're gonna substitute that whole entire thing there, so it's gonna be 1000 all over pi r squared minus 4 over 3r, right? And then we can now multiply this thing inside there using the distributive law. If we do that, we're gonna get 4 pi r squared, then it will be plus, then you're gonna that, now if you do that and that are gonna cancel out, and then that's gonna cancel out, so you're gonna be left, so for this part it will be 2000 over r, then minus what is 4, it will be 2 times 4, which is 8, so it will be 8 pi r squared over 3, and then that's what you're gonna get of what we're looking for. And then basically what you can now do, you can actually take those and take them back in terms of like a negative exponents. So we can have this as 4 pi r squared plus 2000 r to the power of minus 1, and then that is just minus 8 pi over 3r squared. Oh, and then we can add those also, right? Didn't see. We can basically add those. Where's the calculator? So we can say 4 pi minus 8 pi over 3, and we get 4 over 3 pi r squared plus 2000 r to the power of minus 1. Okay, and then that's what we get at the end. All right, now the second step to this is for us to now do the derivative of that and then equate it to nil for us to get to solve for r. So we're gonna say s a equals to 0. Then we're gonna say, if we do that, then we're gonna do the derivative of that surface area. Then we're gonna say 4 over 3 times 2, we get 8 8 pi over 3 r. Then we're gonna get minus 2000 r to the power of minus 2, and then we're gonna equate it to 0. All right, then what we're gonna now do, we're gonna try to simplify everything, ne? So to try and simplify everything, let's just change everything into exponents. So we're gonna into positive exponents. So we're gonna get 8 pi over 3r minus 2000 over r squared equals to 0. Now let's just, to get rid of the r squared, we're gonna multiply both sides by r squared, and if we do that, you're gonna get 8 pi over 3 cubed minus 2000, and that is just basically gonna be 0. All right, and then after doing that, let's also multiply. Okay, basically what we could have done then, let's just make things much easier. We could have multiplied everything by 3 squared, then if we did that, it was gonna be 8 pi r cubed minus 6000 equals to 0. All right, then that was gonna make much of more sense. Then what we can do is take the 6000 to the other side, 6000, and divide both sides by 8 pi. 8 pi, then we're gonna be left with cubed equals to 6000 over 8 pi. To get rid of the r cubed, we're gonna cube root it. Sorry. Oh, why is it not happening? Oh my gosh. cubed, and then we're gonna do that also this side. Yes, we're gonna do the both sides, and then let's just see what the calculator is saying. So it's 6,000 over 8 pi, and when you put that in the calculator you get 6.0203504909. Now let's see, they say that determine the value of r. So the question just wanted us to determine the value of r. So we can now we can now round off to 2 decimal places. So our answer is basically 6.20 meters, right? For the surface area, for the total surface area, area to be a minimum, all right. So these are the steps that you were basically supposed to follow for you to be able to deal with this question. Hopefully everything is clear to you and you are able to do these kinds of questions. All right. All we needed is the r, but what the question could have done, maybe they could have also wanted you to maybe calculate the minimum area. All right. But then for now they only wanted you to only find the radius. Hopefully that's clear to you.